Okay, so what we have done in the last lecture? What we have done in the last lecture, which numerical? With on a building, of 25 meters above. Okay. Do we have solved that problem or we have not solved it? Okay. So in the last lecture, we are looking for the numerical which is on the vertical motion based on vertically upward and vertically downward motion. So we have already seen the equations, three equations of motion. Okay, under gravity, we can call this as motion under gravity. So the last problem was a small steel sphere is thrown vertically upwards from the top of building 25 meter above the ground. Okay, so a building is there. Now suppose this is the ground level. I will draw the diagram. This is the ground level. Now on this ground level, suppose this is a building. Suppose this is a building. What is the height of this building? The height of this building is 25 meters. This is the height of this building. 25 meter. Further, they says that the building 25 meter above the ground with an initial velocity of 18 meter per second. Okay, so it is thrown. So from this point now, from the top of the building, this sphere is thrown. Okay, it is thrown vertically upward. And what is the velocity? The velocity of this initial with the initial velocity. What is the velocity? Velocity it is given as u1 is equal to initial velocity 18 meter per second. 18 meter per second. It is thrown vertically upward. Okay. So how its motion will be? Then what the further they says here? Determine in what time it will reach to maximum height. Okay, so we need to calculate the time, okay, at which it reached to maximum height. The second, how high it will rise above the building. So what is the height above the building? That we need to calculate. Then calculate the velocity with which it strikes the ground. Okay, so when it come back, by which velocity it will strikes the ground, that velocity we need to calculate. And fourth thing is total time for which it is in motion. So we also need to calculate the total time for which it is in motion. So now see, suppose now a general question is there. Suppose now this is a ground level and a ball is thrown from this point. Okay, and it is supposed thrown vertically upwards like this. Now you tell me how it moves or what is the path of its motion. What is the path of its motion? What will happen exactly? तुम्ही इथं ग्राउंड वरती उभारलाय आणि तो उभारून तुम्ही एक बॉल वर फेकलाय समजा. Okay, you have thrown a ball in vertically upward direction. Okay, ज्या वेळेला तुम्ही थ्रो करताना तुम्ही त्याला फोर्स लावता की नाही काहीतरी एखादी गोष्ट तुम्ही ज्या वेळेला थ्रो करता when you are throwing something you are applying force to that. Okay, it means that when you are throwing something then you are applying some velocity to that ball so that it will move upward. Okay, so here let us say that u is your initial velocity. Then how it move? So it will move upward like this. Okay, after some time it will stop at this point. Okay, here at this point half of the stage it stops where its final velocity is 0, and from this point it will start fall down. Okay, and then slowly its velocity goes on increasing, and with the maximum velocity it will hit the ground. This is the total motion. This is the total motion. लक्षात आली का मोशन कशी होणार आहे? इथून जर तुम्ही एखादा स्पियर व्हर्टिकली अपवर्ड जर थ्रो केला तर तो तुम्ही थ्रो केल्या केल्या वेलोसिटी फास्ट वेलोसिटीने वर जाईल, ह्याची वेलोसिटी हळूहळू कमी होत जाईल. मग असा एक पॉइंट येईल एअर मध्येच हवेमध्येच की जिचा याची वेलोसिटी 0 होईल आणि तिथून हा काय होईल खाली फॉल व्हायला लागेल. ओके, आणि मग जेव्हा हा खाली फॉल होईल त्यावेळेला हा जसा जसा खाली येत जाईल तशी तशी याची वेलोसिटी परत काय होणार इन्क्रीज होत जाणार. And with the maximum velocity it will hit the ground. This is the motion of a sphere when you throw it in a vertically upward direction. Okay, now why I have explained you this concept, because now in this problem what they have asked us, so this height, if you see this height is nothing but your maximum height. This height is nothing but your maximum height. That is the point at which your final velocity becomes 0, and from that point that sphere will start moving downward. Okay, so this is your maximum height. This is all asked in the numerical. First point. Second, the time required to reach this height. What is the time required from here to here? Whatever the motion is traveled by this ball or sphere, what is the time required for that? That also we need to calculate. Okay, this is the first part of the problem. Then in the second part they have asked us what is the time. Okay, now this time we already know. Then what is the time from this point to this point? What is the time required? Okay, suppose now this is T1, this is T2. This also we need to calculate. And finally, when it comes near the ground, before striking the ground, what is its velocity? That is also asked. Before striking the ground, what is its velocity? So these quantities we need to find out in this numerical. Okay, पहिल्यांदा तुम्ही बॉल किंवा स्पियर ज्या वेळेला वर फेकलेला आहे तर तो ज्या वेळेला तुम्ही वर फेकताल तर तो वर जाईल आणि एका सर्टन पॉइंटला काय होईल तो थांबल, आणि तिथनं ते थांबल म्हणजे काय थांबत नसतंय वर, तिथं त्याची वेलोसिटी 0 होणार आणि तिथनं खाली फॉल व्हायला चालू होणार. ओके, सो ज्या पॉइंटला त्याची वेलोसिटी 0 होईल दॅट इज युअर मॅक्सिमम हाईट. The time required to reach that height, that is your initial time. Then from this height it will fall down. Okay, and before striking the ground, what is the velocity of this sphere? That we need to find out. That's it. Okay, so very simple problem is there. Now we will solve this problem. कळला काय काय calculate करायचं? Okay, this side, those who are online, have you understood the problem? What is need to calculate?
Yes, sir.
Okay. So now see here what we will do now. We will consider now, see first case. So they see we will solve this problem in two cases. Initially this sphere is thrown vertically upward. So let us say that this sphere is moved vertically upward. Okay, up to this point over here. And at this point its velocity becomes 0. It's this initial velocity which you have given 18 meter per second. Slowly this is decreasing as this sphere is moving up, and at this point suppose this velocity becomes 0. Now consider this motion. Okay, so suppose now height for this height is, suppose this height is h1. Okay, and time required, and the time required for this motion, is suppose t1. In t1 time it will reach to this h1 height. Okay, so first of all we will calculate this t1 and h1. So now here I will write the equation case 1 first. Okay, पहिल्यांदा आपण याचे दोन पार्ट करू. पहिल्यांदा ही मोशन स्टडी करू. दिस इज अवर केस 1, and then from this point it is falling down. This is our case 2. So we will study this in 2 cases. So first of all, its initial velocity, you have thrown it. तुम्ही ह्याला फेकलेलं आहे म्हणजे इनिशियल वेलोसिटी 0 नाहीये, तुम्ही फोर्स लावलेला आहे त्याला. So the initial velocity is 18 meter per second. After some time its velocity will become 0. So the final velocity is 0 meter per second. Now let me know what is the value of g. It is 9.81 meter per second square. Plus or minus? Minus. You should take this minus because this motion is vertically upward motion. The motion against the gravity. This motion, this vertical motion is against the gravity. That is why we have given your negative sign. Okay. So now, if I use the formula that suppose V1, this is our V1. V1 is equal to U1 minus GT1. Okay. So V1 is your final velocity. It is 0, which is equal to U1 is initial velocity 18 minus G is 9.81 and T1 is as it is T1. Okay. So therefore, if you solve this, then T1 is हे मायनस म्हणजे इथं प्लस असते इक्वेशन मध्ये पण जी चं साइन मायनस आहे म्हणून ते इक्वेशन मायनस झालं. ओके. यू रेफर द प्रीवियस पेज, that table. In that table I have given the equations. You refer that. In the last lecture I have given you the equations of the vertical motion and vertically upward motion and downward motion under gravity equations. So if you solve this, you will get the value of T1. What is the value? 1.83 seconds. So this is the value for T1. Okay, this is the value for T1. Now we will calculate height. How do we calculate height now? Use the formula H is equal to UT. तुम्हाला फॉर्म्युला कसा पाठ आहे? H is equal to UT plus half AT square. So A you should replace it by G and G is minus G because motion is upward motion. So minus G T square. Okay. And here it is, we are talking about the first case. So I will give the notation 1, 1, 1 and 1. G la G1 करू नका. G is constant everywhere. Okay. So here from this equation you can calculate this height H1. H1 is equal to, what is the value of U1? Initial velocity is 18 into 1.83 minus half into 9.81 into T1 square, 1.83 square. Therefore H1 is equal to 16. Okay, so it is, please check the answer, 16.51 meter. Is it right?
Yes, sir.
Okay. So have you understood this? What we have done in the first case? Please see the problem once again. Have you understood this? Yes, no?
Yes, sir.
Okay. इकडं ऑफलाइन समजलंय का काय केलंय? नसलं समजलं तर विचारा आता लगेच. परत मग पुढचे प्रॉब्लेम कळत नाहीत, नाही तर लॉजिक तुम्हाला एकदा कळलं नाही लॉजिक कसं लावायचं तर तुम्हाला कळणारच नाही ते. See, I am again and again telling you, in this unit you have to use only 3 equations. 3च इक्वेशन्स आहेत ज्याच्यावर तुम्हाला बाकीचे इक्वेशन्स फक्त लक्षात ठेवायचे. Okay, your 3 equations, V is equal to U plus AT, then your S is equal to UT plus half AT square and V square is equal to U square plus 2AS. हे 3 इक्वेशन आहेत फक्त, या 3 इक्वेशन वरतीच तुम्हाला प्रॉब्लेम सॉल्व करायचे, ओनली बेस्ड ऑन these 3 equations. Okay, and these 3 equations are of linear motion. When the motion changes in the motion changes to gravitational motion, that is the upward motion or downward motion, then you have to replace that A by G. If the motion is upward, you should write minus G instead of A, and if the motion is downward, then you should write plus G. Okay, and you will get all the equations of this motion under gravity. And instead of s displacement, in the linear motion displacement is horizontal, but in the motion under gravity the displacement is vertical, or it is what we can say vertically in the upward direction or vertically downward direction. So we call this as a height in this. So these are the only minor changes in the equation. Everything else is remains same, but just you should think how that motion will be and where its initial velocity, where its final velocity, and how to calculate the time. That's it. Okay, so this is case number 1. Now in the case number 2, what is happened? Now study the motion from this point. Now see, this ball comes at this point. Okay, here. Now from this point it has started falling down and its velocity is slowly now increasing, and it will gain the maximum velocity before striking the ground, just before striking the ground. Okay, it is having the maximum velocity. Now if I consider this motion, here the velocity is 0 meter per second. Okay, so now if I consider this motion, now this is my initial velocity and this will become my final velocity. This is my case 2. Second motion, this is my first motion, and now this is my second motion. Okay, so from this point, when it is started to falling down, here at this point its velocity is 0, and let its velocity be v when it strikes the ground. Okay, or you can call this velocity as v2, and you can call this as u2. Okay, again what we need to calculate, what is the time required over here for this journey, what is the time, t2. This total time also we need to calculate. So I will write here now case 2. Here initial velocity u2 is equal to 0 meter per second. Final velocity v2 we don't know, we need to calculate. Time t2 is also not knowing, we need to calculate. Then height. Now see here, this total height, how much it is? What is this total height? This total height is equal to already the height of the building. What is the height of the building? 25. आणि त्याच्या पुढे हे कुठे गेल्यावरती 0 झालंय तर h1 वरती. h1 किती आहे? 16.51. म्हणजे टोटल हाईट किती झाली? Then what is this total height? This total height h2 is equal to, it is 25 plus 16.51. So how much it is?
41.51.
41.51 meters. So this is the total height. Okay, म्हणजे ही काय झाली त्याची टोटल हाईट झाली. So I will write here h2 total height is 41.51 meter. Now I want to calculate the time. So I will use the equation h2 is equal to ut and half gt square. This is the equation. Now g is plus or minus in the second case. इथे g plus घेणार का minus घेणार? Plus घेणार, कारण motion ही downward आहे in the direction of acceleration due to gravity. Okay, so this is plus. So here I will write plus g. So now I will put the value. h2 is 41.51, which is equal to u2 is 0 आहे. u2 ची value बघा, this value of u2 is 0. Therefore this entire term will become 0. As u2 is 0, this term will become 0. What is remain now? Half into 9.81 into t2 square. So reshuffle the terms and let me know the value of t2. 2.9. Please check the value. This is the value of t2. Okay. आता आपल्याला काय मिळालं? हे टाइम मिळाला. We have also calculated this quantity. Now what is remaining? This v2 is remaining. मग आता तुम्हाला हाईट माहिती आहे, टाइम माहिती आहे, इनिशियल वेलोसिटी माहिती आहे. सो g ची व्हॅल्यू पण तुम्हाला माहिती आहे. सो यू कॅन इझिली कॅल्क्युलेट दिस v2. So here V2 is equal to U2 plus GT2. V is equal to U plus AT. तसंच इक्वेशन लिहिलेलं आहे. V2 is equal to U2 G2. So therefore V2 is equal to U2 is 0. So again this term is 0 plus 9.81 into T2 आता व्हॅल्यू आपल्याला मिळालेली आहे. T2 is 2.9. Therefore what is V2?
28.55.
28.44 का 55?
55.
Okay, 28.4, 28.5. कुठलाही आन्सर घ्या. मीटर पर सेकंड. Meter per second. This is the answer. Now, what is the total time required for the journey? Final question. What is the total time? Total time म्हणजे ह्याला रिलीज केल्यापासून ते ग्राउंड वरती येईपर्यंत किती टोटल टाइम लागलाय? इथून इथपर्यंत जायला किती टाइम लागला? T1. इथून खाली यायला किती टाइम लागला? T2. So your total time will be T1 plus T2. So total time, let us say capital T is equal to T1 plus T2. So total time is equal to, it is 1.83 plus 2.9. So T is equal to 4.73 seconds. If anybody is having any doubt, you can ask me regarding this numerical number. कुणाला काय अडचण असली तर विचारा. Is anybody is having any doubt?
No, sir. No, sir.
इकडे तुम्हाला काय डाऊट आहे का? समजलं? Okay. So take down the next example. The ball is dropped down from top of tower 30 meters high. 30 meters high. At the same instance, at the same instance, at the same instance, second ball is thrown upward from the ground, thrown upward from the ground with the initial velocity of 15 meters per second. Full stop. When and where they do cross each other, they do cross each other. Now read the problem carefully and try to imagine that what is given in the problem. So if you try to imagine this with the help of diagram, this is the ground level. Okay. A ball is dropped down from the top of tower 30-meter high. So we will draw the tower. This is the tower. What is the height of this tower? The height of this tower is 30 meter. Okay. So one ball is there which is dropped. Okay, so this is 30 meter. Now this is sphere number 1. Now this ball is dropped from this. Okay, drop म्हणजे काय? When you are dropping anything, you don't apply any force. Drop म्हणजे काय? हे मी असं धरलेलं सोडून दिलं. This is drop. This is called as drop. Okay. So, okay. See here, what is the drop exactly now? I am holding this. And when I leave this, it will move downward. Okay. Without applying any force on this. I am not applying any downward force on this. Okay. Still what is happening? If I leave this, it will fall down. So this is called as drop down. Okay. Or drop. This is called as drop. Drop means what? The initial velocity, I am not providing any initial velocity to move that ball downward, but it is still moving downward due to acceleration due to gravity. तुम्ही कुठलीही गोष्ट इथं जर सोडली तरी खालीच जाणार आहे, वर जाणार नाही. When I drop, but when I apply some force, then it will move up. Okay, so when you apply something for throw it, then there is a initial velocity is not zero in that case. But when you are dropping something like this, just leaving that thing, then initial velocity is zero because you are not throwing it downward. समजते फरक? हे सोडणे असा आणि ह्याला थ्रो करणे ह्याच्यामध्ये फरक आहे. बरोबर आहे ना? So when you throw it down, then your initial velocity is not zero. But when you drop something, then your initial velocity is zero because you are not applying any force. Okay, it is moving downward because of acceleration due to gravity. Okay, so now this is the first ball. See, this is the first ball and it is dropped, okay, from this point. So when you drop this, it will move down. Okay, and when it is dropped, its initial velocity must be 0 meter per second. As it is dropped, it is not thrown. थ्रो करणे आणि हातातनं सोडणे किंवा सुटणे ह्याच्यामध्ये फरक आहे. Okay, when you throw something, you apply the velocity, but when you drop, you won't apply the velocity. Okay. So now see, at the same time, एवढंच वरती ते थांबलेलं नाहीये, तर at the same time what is happen? There is another ball. See, suppose now this is the another ball. Now this ball, what is the wording? See here, at the same instance. Instance means time. Okay, so at the same time, second ball is thrown upward from the ground. So ज्या वेळेला हा बॉल ड्रॉप केलाय त्याच वेळेला हा बॉल काय केलेला आहे, वर थ्रो केलेला आहे. So this ball is thrown vertically upward at the same time with the velocity of 15 meter per second. So what is the initial velocity of this ball? Suppose this is second ball. So I will call this as U2, 15 meter per second. And I will call this as U1 for ball 1. Okay. So the question is when and where they do cross each other. See, whenever this type of question is there, when and where. So you need to calculate two things. When means time. When means time. And where means distance. बरोबर ना? आपण विचारत नाही का कधी यायचं आणि कुठे यायचं. तो तुम्हाला जर कुठं जायचं असेल किंवा कुठल्या कुणाला जर भेटायचं असेल तर व्हॉट इज अवर क्वेश्चन? कधी येऊ आणि कुठं येऊ. So the question is when and where. Kadi you means you are asking time, that is when. Okay, and kuta means where, that is the distance. थोडक्यात तुम्ही ऍड्रेस विचारताय म्हणजे ते काय, you are seeing the distance from your place how far it is. So when and where means time and distance. Okay, so that we have to calculate. And the when and where they do cross each other. म्हणजे एक वरून सोडलाय एक खालून थ्रो केलाय तर ते कधी एकमेकाला क्रॉस करतील कुठल्या वेळेला हे तुम्हाला त्यांनी विचारलंय प्रॉब्लेम मध्ये. इज इट क्लियर? व्हाट इज द गिवन प्रॉब्लेम? नाउ यू टेल मी हाऊ यू विल अप्लाय द लॉजिक अँड हाऊ विल यू सॉल्व दिस. थिंक ऑन दिस. अनलेस अँड अंटिल यू थिंक ऑन इट. इक्वेशन तर तीनच वापरायचे परत सांगतो मी तुम्हाला. काय करायचं ते समजून घ्या. प्रॉब्लेम काय दिलाय. Here there are not so many formulas which you are going to use over here and to solve the problem. There is only three equations are there. By using that only you have to solve the numerical. See what I will say. समजा मी काय म्हणतो की हे जे आहेत, I will draw one line here. Suppose now at this point they will cross each other. At this point ही जी मी लाईन ओढली आहे ना या लाईनला हे या पॉइंटला हे क्रॉस होतील. म्हणजे हा इथून असा खाली खाली येईल त्याच वेळेला हा इथून असा वर वर जाईल आणि ज्या वेळेला हे पॉइंट येईल त्यावेळेला फर्स्ट बॉल हा इथं असेल आणि सेकंड बॉल हा इथं असेल. ओके. So this is the distance. So we don't know what is that distance. So what I will say, suppose this distance is h. Suppose say that this distance is h. Still we don't know what is the distance. Just we are saying that this ball is moving downward and at the same time this ball is moving upward. So at some instant they will cross each other. Okay. At that instant this height is suppose h. Okay, I will call this height as काय पण म्हणा तुम्ही इथे U2 वापरायचं राहिला H2 म्हणा किंवा H म्हणा. काय घ्यायचं नोटेशन आपण? H2 घ्यायचं. ठीक आहे H2. Let us call this as H2. So now if you call this as H2 then what will be this? ह्याची हाईट किती झाली मग? ही हाईट किती झाली? This total is हा बॉल कुठून रिलीज केलाय? ह्याच्या टॉप वरनं रिलीज केलाय ना इथून. Okay, the ball is released from the top, from here. Now, if this total is 30, this is H2, then this remaining will be 30 minus H2. Okay, this is the initial thing. So now, say I will write here. Consider motion of second ball. Now consider the motion of second ball. What is given? Okay. बघा इकडं second ball जर मी consider केला. What is the distance it travel? Height. Height is equal to what? What is the height of this second ball? How far it have traveled? H2. Height is H2. We don't know. Okay. Then what is the initial velocity with which it is thrown vertically upward? 15 meter per second. Okay. we don't know in how much time it will move, reach there. Okay, so if I continue this same line here, in this way, okay, so let us say that the time required by this second ball to reach to that this point, this time required is t2. This time required is t2. Okay, so instead of t2, suppose first of all we will call this as t. आता बघा मी ह्याला सोडतोय इथून, त्याच वेळेला ह्याला थ्रो करतोय, दोन्ही एकाच वेळेला करतोय. हे सोडलंय नंतर हे थ्रो केलंय असं सांगितलेलं नाही, किंवा हे थ्रो केलंय त्याच्यानंतर थोड्या वेळाने ह्याला सोडलेलं आहे, ड्रॉप केलेलं आहे असं नाहीये. These are two balls and at the same time I will drop this ball and I will throw this ball vertically upward. एका कुठल्या तर टाइमला ते क्रॉस होतील का नाही, मग ते ज्या वेळेला क्रॉस होतील, समजा 2 सेकंदानंतर ते क्रॉस झाले, किती सेकंदानंतर, 2 सेकंदानंतर इथं या पॉइंटला, तर ह्याला वरून या पॉइंटला यायला किती वेळ लागला, किती वेळ लागला, 2 सेकंड्स, आणि ह्याला खालून इथं वर जायला किती वेळ लागला, 2 सेकंड्स. समजते का काय सांगतोय ते. This online, those who are online, are you getting the concept?
Yes, sir.
See, this is one ball, this is second ball. I am doing it simultaneously. एकाच वेळेला मी ह्याला ड्रॉप केलं आणि ह्याला वर फेकलं, तर हे दोघं काय झाले, हा ड्रॉप होत खाली आला, हा वर वर जात या पॉइंटला हे दोघं क्रॉस झाले. ओके, या पॉइंटला हे दोघं क्रॉस झाले. समजा हे क्रॉस 2 सेकंदांनी झाले, मी इथनं सोडलं आणि इथनं फेकल्यावर एक 2 सेकंदांनी हे दोघं एकमेकांना क्रॉस झाले आफ्टर 2 सेकंड्स. मग मला सांगा या लेवलला हे दोन बॉल आलेले आहेत सध्याला. प्रिव्हियसली बॉल 1 कुठं होता, टॉपला होता, त्याला इथून इथे यायला किती वेळ लागला,
2 seconds.
2 सेकंड्स. आणि प्रिव्हियसली हा जो सेकंड बॉल आहे हा कुठं होता, खाली होता, त्याला थ्रो केला आपण, ह्याला या पोझिशनला यायला किती वेळ लागला, 2 seconds. So the time is same. Okay, so here whatever time is required by this second ball to reach to height h2, the same time required by the first ball to reach the height 30 minus h2. Okay, so the time for both of them is same. Okay, so I will write here time is equal to t seconds. Time is equal to t seconds. And what is the value of g? Acceleration due to gravity g, it is minus 9.81 meter per second square. Okay, now if I use the formula, h is equal to ut and half g is minus g, so minus gt square. This is the formula. Okay, so here if I put the values, h is nothing but, we are thinking about second ball, so here h is nothing but your h2, u is nothing but it is u2. Okay, t will be as it is because time is same for both of them, minus half into 9.81 t square. Now solve this equation. So h2 is equal to u2. What is the value of u2? It is 15t. This is minus 9.81 by 2. किती? किती येते हे?
4.90.
4.9 t square. So let us say that this is our equation number 1. Okay, now consider the motion of first ball. Consider motion of first ball. Now if I consider the motion of first ball, see this is my first ball. What is its initial velocity? 0. What distance it is traveled? This is 30 minus h2. Okay, and what is the value of g here? It is plus or minus. So
Plus.
here G is plus because this is moving downward. It is moving in the direction of acceleration due to gravity. म्हणजे गुरुत्वाकर्षणाच्या डायरेक्शनला जर एखादी गोष्ट जात असेल तर जी ची व्हॅल्यू पॉझिटिव्ह घ्या. गुरुत्वाकर्षणाच्या विरुद्ध डायरेक्शनला जर एखादी गोष्ट जात असेल तर त्यावेळेला जी ची व्हॅल्यू काय घ्यायची, निगेटिव्ह घ्यायची, विसरू नका. सो नाव हिअर काय सांगत होता तुम्ही, first case. Okay, consider the motion of first ball. Now here you can see initial velocity, height is known to you, time is known to you. So if I use the formula, then initial velocity u is equal to, it is 0 meter per second. Then time is equal to, what is the time? It is t seconds. Then height. Now see, if this is h2, then what is this height? 30 minus h2. So I will write here height 30 minus h2. This is the height. Okay. And then what is the value of g? G is 9.81. So here h is equal to ut and gt square. So here g is plus because it is moving down. So now here if I write for the first ball, this h height is what? Height is 30 minus h2. This is the height. Initial velocity is 0 plus half into g is 9.81 into t square. Okay. So again you will get one equation. What is that equation? What is the equation you will get from this? So it is 30 minus h2 is equal to 4.9 t square. This is your equation number 2. Now solve equation 1 and equation 2. सोडवा कॅल्क्युलेटर वर फास्ट. जमतंय का? हा? काय म्हणतोय? हा हा 1 ची व्हॅल्यू 2 टाका का 2 ची व्हॅल्यू 1 मध्ये टाका. Okay, so what he is saying now, we are having equation 1. Okay, so this is our equation 1. Here we have already got h2 is equal to 15t minus 4.9 t square. So this is the value of h2. So he is saying that put this value of h2 in equation 2. Okay, so here you can do it in this way also. So if you put that value, so instead of writing, I will directly put. So 30 minus here, what is the value of h2? h2 is 15 minus 4.9 t square. So 15t minus 4.9 t square. Okay. Is equal to 4.9 t square. Is it right? Okay. So here it is 30. This is minus 15t. Then this is plus 4.9 t square, which is equal to 4.9 t square. So this will get cancelled. So this will get cancelled. This is also cancelled. So t is equal to how much? 2 seconds. So the answer is 2 seconds. अजून आहे का पुढं? Height काढायची. Okay. So now again we need to calculate the height. So in any equation you can put this value of t. Either you can put it in equation 2 or equation 1. So here equation 2 is there. So put this value of t in equation 2. So it is 30 minus h2 is equal to 4.9 into t square. So 2 square. Therefore h2 is equal to 10.4. Please check the answers.
It is correct.
Okay, so if you have asked what is the velocity of first ball at that point when they cross each other, what is the velocity of this first ball which is dropped from certain height, okay, from the top of the tower? What is the, what we can say, velocity of that first ball at that point when these two balls are cross each other? Tell it 2g means 19.62. Correct. That is the correct answer. Okay. So those who have not understood, I will tell you what I have told right now. Suppose now at this point the problem is over. What is I am telling now below this red line? Okay. ही जी रेड लाईन ड्रॉ केलेली आहे मी, ह्याच्यामध्ये आता काय जे तुम्हाला सांगणार आहे दॅट इज एक्स्ट्रा. म्हणजे जर असं तुम्हाला प्रॉब्लेम मध्ये विचारलं असतं तर तुम्ही काय केलं असतं ते सांगतो. ओके. सो नाउ सी वी हॅव अज्युम दॅट these two balls will cross each other at this point. So my simple question is, this ball is dropped from certain height. Okay, now we know the height also. This ball is moving upward. Okay, so this will also reach to this height. So my question is, what is the final velocity of this first ball v1 at this point? v1 म्हणजे या फर्स्ट बॉलची व्हेलॉसिटी काय असेल इथं आल्यावर, किती असेल? That is my question. Are you getting the question? Okay. Now see the solution. Solution is very simple. What I need to find out? बघा एक गोष्ट लक्षात घ्या, तुम्हाला जरी कळलं काय कॅल्क्युलेट करायचंय, इथं बघा इथं अननोन काय, आपल्याला काय कॅल्क्युलेट करायचंय? व्हेलॉसिटी. हाऊ मेनी फॉर्म्युलेज वी आर हॅव्हिंग? v इज इक्वल टू u प्लस एटी. मी कधीच ह्याचे फॉर्म्युले लक्षात ठेवत नाही किंवा ते ठेवायची गरजही नाही कुणाला. तुम्हाला हे 3 फॉर्म्युले माहितीत, त्याच्यावर नाही लिहायला शिका कसं लिहायचं. ओके. सो v is equal to u plus 80. Then second is s is equal to ut plus half 80 square. And what is third? v square is equal to u square plus 2s. मला जर v कॅल्क्युलेट करायचा असेल तर मी हे फॉर्म्युला वापरायला कशात जाणारच नाही. मी या 2 फॉर्म्युल्यातनच बघणार की मला कुठला फॉर्म्युला युजफुल आहे. करेक्ट. मला जर v कॅल्क्युलेट करायचं आहे, नाउ वी वांट टू कॅल्क्युलेट v, वी विल नॉट लुक दिस फॉर्म्युला बिकॉज इट डजंट कंटेन v. Velocity is not there. So I will look into these two. So if I look into first one, आता या दोघांपैकी मला कोण आन्सर देऊ शकतंय? So if I go to this first one, I need to calculate v. So I will write here v1, v2, whatever it may be. U plus 80. So how much u? U is 15. Okay, initial velocity. And no, initial velocity is 0. We are talking about first ball, no? So initial velocity is 0 and g is 9.81. And what is the time t? Time we have already calculated. What is the time? 2 seconds. Okay. So if I put all these values over here in this formula, I will get the answer from here itself. I will get the value of v, that is velocity at this point. So here if I write velocity of first ball when they cross each other. Okay. Velocity of the first ball when they cross each other. Let it be v1. We don't know. So what I will use? I will use the formula v is equal to u and at. Now I don't remember the formula. So it is u is there. A should be replaced by g. So I will write here g. And this motion of the first ball is downward motion. So this g is plus. Okay. So this v nothing but velocity v1 is equal to u1 plus gt1, which is equal to 0 plus 9.81 into 2. So v1 is equal to 19.62 meter per second. This should be your final answer. Okay. समझला का प्रॉब्लम?
Yes, sir.
Yes.
Good. Now if you understand this problem, now we will take next one. A stone is thrown stone. टेस्ट आहे का तुमची? मग सांगायचं की मला 5 वाजले का? किती वाजता टेस्ट? किती वाजता पेपर?
लिंक कॉलेज
साडे चारला आहे. बरं ठीक आहे. Okay, so there is one more announcement. From here onwards, even though sometimes if I may not be there in the college due to some reason, due to duty leave or some anything else, our online lecture will be there as per our timetable. Okay, because now your draft timetable is out. So I think so. It is now on 8th applied paper is there. So that is the draft timetable. So maybe 8 or 8 to 12. या कुठंतरी फायनल टाइम टेबल म्हणजे या ड्युरेशन मध्ये बसणार तुमचं 12 तारखेच्या आजचं. So even though if I am not there in the college sometimes, then you should be there offline. Those who are coming offline, all of you are having mobiles with you. So you can attend it online also, even though you come here. Okay. And for those who are attending online, they are not having any problem. Okay. So in the next lecture, we will take the next numerical. Now only one numerical I will take of the different what we can say logic, and then we will take motion under variable acceleration. Okay. बाकीच्यांचा सिलेबस काय झाला बघितलं का जरा बाकीच्या क्लासेसचा? कुणाला विचारलंय का? तुम्ही विचारलंय का ऑनलाईन कोण आहे का असं ज्यांनी विचारलंय बाकीच्यांना कुठपर्यंत आलाय?
6 युनिट झाले सर. सी डिव्हिजन.
हा
सी डिव्हिजनचे 6 युनिट झाले.
6 युनिट कुठल्या डिव्हिजनचे?
सी डिव्हिजन.
ए डिव्हिजन.
सी
डिव्हिजन. Who is teaching for C division? Okay. So now Okay, so today is 15th or 16th. What is the date? 15th. Okay, so give me the attendance now. Roll number 1, 2,
Present, sir.
3, 4, 5,
Present.
6. Roll number 6, 7. Roll number 7 present. 8, 9, 10,
Present, sir.
11, 12, 13, 14, 15,
Present,
16,
sir.
16, 17,
Present, sir.
18, 19,
Present.
20,
Present, sir.
21,
Present, sir.
22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
26, 27,
Present, sir.
28,
Present.
29, 30, 31,
Present.
32, 33,
Present, sir.
34, 35,
Present, sir.
36, 37,
Present, sir.
38, 39, 39, 40, 41,
Present, sir.
42,
Present, sir.
43, 44, 45, 46, 47, 48, 49, 50, 51, 52,
Present, sir.
53, 54,
Present, sir.
55, 56,
Present, sir.
57, 58, 59,
Present, sir.
60, 61. Okay. तुमची टेस्ट कुठे इथंच आहे कसं आहे ठीक आहे
61 is present, sir.
61 is present. 61 is present. Okay. See the roll number 6, 13, 18, 29, 32, 39, 40, 44, 47, 49, 50, 51, 58, 56. These are the absent roll numbers. So 14 students are absent.